There's a little bit of homework help for Unit 5, Lesson 18, Scaling in 2 Dimensions. In the previous lesson, we talked about working with just one dimension where we substituted a value and multiplied that value to recognize how a volume or a height or something changed as a result of just one dimension being changed, such as the height. In this case, we're going to be looking at, again, 2 dimensions. So letting you skip over one of these problems, so I didn't assign everything to you. So we'll start right here. First part, as part of a competition, Diego must spin around a circle 6 times and then run to a tree. The time he spends on each spin is represented by S, and the time he spends running is R. He gets to the tree 21 seconds after he starts spinning. We need to remember that all of these pieces of information are represented within our equation. So when we talk about an equation showing the relationship between S and R, I want to have S and R in one part of the expression, and then I want to have a comparison of the time, the total time, in the other part of the expression, because it's showing a relationship between S and R. Granted, you can write these in different ways, but there's one preferable method that I'll be talking about here. In this first part of it, we need to recognize that he's running around the circle 6 times and then running to the tree. The time that he spends on a spin is S, and the time spent running is R. So it's important to recognize how many spins he has and then how much time is running around that tree. So we should recognize that it's the time, or the number of spins, and the time that's spent on that, or the time per spin, plus the time to run to the tree, must be equal to the total time. Okay, hopefully that's enough information to really get started there. Once you have that information, you're going to rearrange the equation so that it shows R as a function of S, meaning rearrange your equation. So let's say if you just had some equation, I don't know, let's think super random, like, let's say 6 times, you thought that I was going to give it to you. I'm not going to. Let's say that if we're talking about the amount of times around the tree, is S is equal to 21 seconds minus the amount of times around the tree divided by 6. There's a good spot for it. Question is, how would you get R by itself? This is where we need to use the properties of equality to solve for R. And so we would just run through those pieces of, since I divided by 6, I want to multiply by the reciprocal, which is 6, and multiply this side by 6 as well. We get the idea, get it so that we have just R all by itself, and that will give you a new expression that still has the S and the 21 somewhere in there, and the 6. It'll all be represented if you do it the right way. If it takes Diego 1 and 10 seconds to spin around each time, how many seconds did he spin running? Well, then we need to consider those pieces about how many spins he had. He had 6 spins plus the 2 seconds, or the 1.2 seconds per spin, plus the amount of time that he spent running around the tree would have to be equal to 21 total seconds getting around, or getting his spins plus the running. So you need to be able to figure out what R is in this case, because that's what we don't know. Oh golly, did I just give you that equation for the first one, part A? Oh my goodness, can't believe I did that. You're welcome. This next one, part A, it says for what values of X is the input from the table less than the output on the graph. Read this one very carefully, recognizing a few things, that for which values of X is the output less than the output from the graph. So you're going to look at these outputs and find out which values here are represented differently on this graph. Keep in mind, this graph is not a representation of this table. So this table and the graph represent two different functions. And so you're going to have to really look at the data for both of them and figure out how to add those data to both of them. Perhaps you want to go and do the page marker thing where you click on this guy right here, and then you just go ahead and start labeling your ordered pairs 1 and 3, 2 and -1, right? Take a look at those pieces and then make the comparison for this question. Select all that apply. The following question with this one, I'm not sure why it's not working now. Oh, never mind, it's because of this page marker. Let's go back to this. The next question talks about in the graphed function, which values of x give the output or give an output of 0. So only looking at this function right here and thinking about which values of x give or go with the output of 0. So we can look at the output of 0, which is the x-axis. So think about those values based on the graph, select all that apply, and then we're going to work on the next problem. A cone has a radius of 3 units and a height of 4 units. Again, this is going back to more review. So a cone has a radius. Let's just do a cone right here. We see a radius of 3 units and a height of 4 units. What is the volume of this cone? Use pi. You did a really good job on your quiz lately, so just remember that the volume of a cone is 1/3 the volume of a sphere. So if we're ever going to be comparing a volume of a cone to a volume of a sphere with the same measurements, what we can remember with that is that the volume here, whatever it is, over here in that, if we took a volume of a cylinder of the exact same height, the exact same base, then we're going to just take that value and go 3 times bigger, because the cone is 1/3 the size of a cylinder with the same measures. So if we talk about this piece where we just go through the final question here is quadrupling the radius but keeping the same height, how many times larger is the new cone's volume? Well, thinking about that new cone's volume, if we're going to quadruple the height, what kind of effect does that have on the total volume? If we quadruple the height, then what we're looking at with this is simply multiplying the right side, multiplying the height right here by 4. And to maintain balance and equality, we have to consider if I'm going to multiply the expression on the right, then I better multiply the expression on the left by the same value. That's it for this homework. Email me if you have any questions. Thanks for tuning in. I hope you have a great day.